Alright, so now we're going to do a couple mixed problems between sample means and sample proportions. 9.42 on our packet. High school dropouts make up 14.1% of all Americans aged 18 to 24. A vocational school that wants to attract dropouts mails an advertising flyer to 25,000 persons between the ages of 18 and 24. A. If the mailing list can be considered a random sample of the population, what is the mean number of high school dropouts who will receive the flyer? Okay, that's a pretty easy question. We're going to use the fact that it is a random sample. We're going to use and carry down that p-value equals 0.141. We know that. And our n for the problem is 25,000. So if we want to know how many people of the 25,000 that we're mailing it to is going to receive the actual flyer, it's basically the product of these two numbers. So it's going to be 141 times 25,000, and we get, with our calculator, 0.141 times 25,000, we get 3,525 people who will receive the flyer out of the 25,000 people. Moving on to part B. Part B talks about what is the probability that at least 3,500 dropouts will receive the flyer. Okay, so we're going to keep this as a sample proportion problem because we don't know anything about the standard deviation in this question. And the only formula that we have for standard deviation is to find it right now from scratch is going to be a sample proportion problem. So we're going to keep this as a sample proportion problem. And what we know is we know that the p is going to equal 0.141, which we know is going to be that p hat value. We can assume that is going to be for the sample. And we're looking for the probability. So let's write this in the language that we talked about in class. So I want the probability that the p hat value is going to be at least, which means greater than or equal to, and I'm going to write this now as a proportion, 3,500 out of our 25,000. Okay, continuing to change this. This is going to be the probability that our p hat value is going to be greater than or equal to 3,500 divided by 25,000, and we're going to get 0.14. And since we're dealing with greater than or equal to, this becomes 1 minus the probability that that p hat value is going to be less than or equal to that 0.141. Okay? Now, for us to be able to find a probability question or an answer to a probability question with sample proportions, we have conditions that need to be met. And those conditions are 1, SRS, and it states it in the problem. It says assume that this mailing list can be considered a random sample. So check, stated in problem. Number 2, that our population is at least 10 times the sample. Okay, and our sample n is 25,000. And we look and it says, according to the problem, of all Americans aged 18 to 24. So our population is Americans between the ages of 18 and 24, and we can assume that the population of Americans between 18 and 24 is going to be at least 10 times that sample, 250,000. That's a good assumption. We can do that. And then number 3, we need to test that n times p is greater than 10, and n times 1 minus p is greater than 10. Our n is 25,000. Our p is going to be 0.141. And when we go ahead and do this with the calculator, we're going to get 25,000 times 0.141, and we get 3,525, and that's definitely greater than 10. And then we're going to do 25,000 times the difference, 1 minus 0.141, That's going to be 0.859, and obviously this is going to be greater than 10, but if you want to just write that down in terms of a number, it's simple, quick calculation. 21,475 is greater than 10, and we showed it. So our conditions are met. And remember, this last condition, this one here, allows me to talk about this distribution as being normal. And this one, population at least, allows me to use the standard deviation formula, p times 1 minus p over n. So everything is in place to be able to now finish this problem. All right, so let's continue. I want to continue with the fact that we're going to need this standard deviation formula, so I'm going to come down here. So our standard deviation is going to equal the square root of 0.141 times 0.859 divided by 25,000. Okay, and again, with the calculator, we're going to get 0.141 times 0.859. I'm going to divide that by 25,000. And I'm going to square root my answer. And I'm going to get excuse me, 0.0022. All right. So now to answer this question, we're going to assume the distribution is normal. We're going to use our mean from our population, and we're going to use the standard deviation we just calculated. And what we have to do is we have to change this 0.14 to a z-score. So z is going to equal 0.14 minus my mean, 0.141, divided by that new standard deviation, 0.0022. So this is going to become 0.001, and it'll be negative, over 0.0022. So we get a negative 0.001 divided by 0.0022. And we get a negative 0.45, we'll take for now. And that's my z-score. So now this problem becomes 1 minus the probability that z is going to equal negative 0.45. And now we can finish this problem up. 1 minus probability that z becomes a negative 0.45. We can look up on our table. So I flip that table over. See if I can get you guys to see it too. There it is on the bottom. So negative 0.4, go over to 5. There it is, 3264. So come back. Make sure we're set up here. This is going to be 0.3264, which is going to equal 1 minus 0.3264. And we're going to get 0.6736 as an answer. Okay, so that's part A is up here, part B is down here. Hopefully we learned how to go through a sample proportion problem.